have exercise 3 here. We have a parabola minus x squared plus 4x, and under it we're going to place a rectangle with one corner in the origin, the other corner on the x-axis, and the third corner on the graph of f of x. And we should find this area function again. There's always, or nearly always, exercise A. And again, we start with the formula of the area of such a thing, which in English I guess is like this. It's 1/2 times the baseline times the height, and the baseline here is actually equals to x. We have to identify what is x here. We're going to find an area function as a variable of x, and it's a function of x, so we have to identify x, and x is the x coordinate of this point here. Right? So here we see in this example, this is just a random rectangle which I've drawn here. You see that x is 3.2. The x coordinate at this point is 3.2 approximately, and then the baseline is 3.2. But I could might as well have drawn this rectangle instead, right? And then the x coordinate at this point will be 2.5, and then the baseline is 2.5. So the baseline is equal to x, which is the x coordinate of this point here. And then I need to find the height, and the height is always restricted, I don't know if that's the correct word, by the graph, right? It's the graph that decides how high the rectangle is, right? If x is equals to 3, then the height is this much, the y coordinate at this point here, right? If x is equals to 2, then the height is this, the y coordinate at this point. So the height is equal to the y coordinate of each point. When I first decide x, I get the height is the y coordinate, and the y coordinate is of course given by f, as y and f of x is the same. If x is 3, then the height is f of 3. If x is 2, then the height is f of 2. But here the x coordinate is x, so the height is y, which is the same as f of x. So the height is minus x squared plus 4x. That is the height. So it's decided by the function. So then the area here becomes 1/2 times the baseline times the height, like this. And then I just multiply in here. So I get minus 1/2 x to the power of 3. I multiply here, and I multiply here, I get plus, and 4 times 1/2 is 2, so I get 2x squared. So here we have the area as a function of x. And then I just want to find the maximum point of this. We want to maximize this area, so I have to find a maximum point. I can do it graphically. Here it says use cos to find it. I don't show this. I'll show this in task 1 and 2. You should also be able to find this by pen and paper. That's more fun. Oh, it's not fun, but it's a bit more difficult. So I just show it quickly here. Then I have to find the derivative. I keep the constant 1/2. Differentiate x to the power is 3, which is 3x squared, plus keep the constant 2. Differentiate x squared, move 2 down, so I get 4 times x. And then this is minus 3/2x squared plus 4x. Here we have the derivative. So this will take some time. So you have to be patient here if you want to see how well it is. But then I put the derivative equals to 0, like this. And this is a equation with the fractions. We don't like fractions in equations. I just multiply by 2 in each term, and then I get this answer here. And then I want to solve this equation. I can factorize. I have x in common here, so I get minus 3x plus 8 equals to 0. So then x has to be 0, or this has to be 0. It's quite hard to see what x is here. Maybe it is a fraction here. But if I can't see which x value which makes this 0, I just put it equals to 0 like this. Solve the equation by isolating x, move this over, divide by minus 3, and I get x is 8/3. So we have 2 stationary points. So here we have some points like this, right? I have to decide which is max, which is min, and so on. So we have to find the sine line of the derivative and the derivative is this here. That's the derivative, right? Like that. Quite hard to find. We could factorize, that's what you normally do, and then try and find the sign line. But the easiest thing here, this is fraction and so on, is to remember that if I want to find a sign line on the derivative, I can just draw the graph of this one. This is a second degree function. This is a parabola. So it's either like this or like this. But we see that the term with x squared is negative, which means that it's angry, like that. Okay. So we have this is a parabola. The graph of this looks like this. And then we can find the 0 points, but that's what I've done here. This is 0 when x is 0 and when x is 8/3, and it is angry, like this. So we see this is the derivative. So the derivative is first negative, then positive, and then negative, right? So we can draw a sign line here when x is 0, x is 8/3 by just looking at the graph of the derivative. It's first negative, then 0, then positive, then 0, and then negative. Oh, sorry. So this means that this is the sign line of the derivative, and then we know a lot about the function. It decreases, increases, and decreases. So this is the minimum point, and this is a maximum point, as we would expect. So this is the maximum point. So we know that this is the maximum point. So here we have the maximum area, and to find the actual area, maximum area, we have to put the x coordinate into the function, which we have here. So we have some work left here. We have to take 8/3. This is going to be messy. 2 times 8/3 square. And then we get a lot of fractions here, minus 1/2 and 8 to the power of 3. 8 times 8 times 8, that is 64 times 8, which is 512. Plus 64 times 2, which is 128/3. So we get minus 512 divided by 2 plus 128 divided by 3. We have to find the common denominator, so I have to do this. And this is minus 1536 divided by 6 plus 256 divided by 6. So what is this thing? We get the negative answer. Can't get a negative answer. I've done something wrong here. Yes, sorry, I forgot to divide by 27 here. Divide by 27, so this should be 27 here, forget about this. 27 it says here. And then I have to multiply by 9 here. So I get, what do I get? This was exhausting. Minus 1, 2, 5, 1152, I think here. This is minus 512 plus 1152, and that will be, and this divided by 27. Yeah, you won't get this on the test, okay? 620, is it? I don't know if it's correct. 620 divided by 7 is my answer. Probably wrong, but you see what you have to do here, okay? So that was exercise 3.